Welcome. This presentation is entitled Closing the Value Action Gap, Examining Landscape Architecture in a Zero Carbon Future. Thank you for selecting and watching this presentation, and thank you as well to the 2020 Pennsylvania-Delaware ASLA Chapter Conference Committee for selecting this presentation and including it among all others. My name is Rob Cooper, Associate Professor of Landscape Architecture at Temple University in Ambler, Pennsylvania.
Hi, I'm Steve Austin. I teach landscape architecture at Washington State University in Pullman, Washington. So I'm coming to you from across the country today.
This presentation includes 4 learning objectives, wherein presentation attendees will realize that climatic change is happening faster and causing worse effects than anticipated. They'll also understand the urgent need to stop burning fossil fuels, anticipate how reductions in fossil fuel use will affect material specification and landscape construction, and finally, participants will recognize how fossil fuel use reductions will affect landscape architectural practice, education, and organizations. This presentation is organized into 3 sections. The first 2 learning objectives Steve will address in the first introductory section. He'll then address the 3rd learning objective in the second section about materials and construction practices, and I'll conclude the presentation by addressing the 4th learning objective, as well as summarizing any main points that we really want to emphasize and any concluding thoughts and actions that you might take.
In order to understand the need for dramatic action on climate, it is vital to understand where we are in the crisis. So I'm going to walk us through some of the key background for the rest of our presentation. Bottom line is the crisis is accelerating. Global temperatures are already nearly 2 degrees Fahrenheit or 1 degree Celsius warmer than the 20th century average. I'd like to mention briefly that the temperature ranges I'm going to be talking about might seem small or even insignificant, but in a wonderful reflection of the interconnectedness of life and our planet, it turns out that climate is as sensitive as a human's body to increased temperature. A rise of 2 degrees in our bodies is the beginning signal that something is wrong, and the same is with the planet. There's no quickly going back, but we've got work to do to not make it worse than it already is and to do our part to reduce temperatures. We're already at a pretty scary place relative to CO2 in the atmosphere, and we don't want to continue that trend. Quite simply, we're creating a greenhouse. The sun's energy can get in, but the heat cannot get out due to being trapped by CO2. We have left the stable climate of the Holocene, where humans first evolved 300,000 years ago, and are entering into uncharted evolutionary territory. This is a closer view of the CO2 trajectory, and to reiterate, we are leaving what we knew as our safe operating zone far behind. Rapidly so. Right now, our CO2 emission rate is 14 times higher than at the time of the greatest biological catastrophe in Earth's history. As a refresher, I'll talk about the primary causes. First, it's burning fossil fuels. Next is industrial agriculture. And third is deforestation, which is getting worse. So now we'll take a look at some of the indicators that show just how hot it's getting. This summer was the hottest on record, well over 2 degrees Fahrenheit or nearly 1.5 degrees Celsius hotter than average. This summer was preceded by the warmest winter on record, some places being as much as 18 degrees Fahrenheit hotter than average. Extreme temperature records are being set, and not just in Death Valley. It reached 100 degrees above the Arctic Circle for the first time ever this summer. On the other end of the planet, Antarctica topped 68 degrees for the first time ever during the southern summer. Thus, not surprisingly, 2020 is on track to be the hottest year ever on record. This is certainly consistent as the last 10 years were the hottest on record, as were the 10 years before that. So what is this heating doing? Well, it's making fires worse, for one thing. So much has happened this year that it's hard to remember back to the beginning of the year when Australia was on fire. Fires there burned nearly 72,000 square miles. For comparison, Pennsylvania and Delaware together amount to 46,675 square miles. Thus, the fires burned more than 1.5 times the area of those states. Fires in California this year have burned over 7,800 square miles. This is more than 1.5 times of the entire Philadelphia combined metro area. Now, climate change doesn't cause wildfires, and certainly inappropriate forest management can make them worse, but there is no doubt that the climate heating increases the drying of the forest, making them more susceptible to large, rapidly spreading fires. 4 of the largest 5 fires in California's history have occurred this year, and 17 within the last 20 years. This is not a coincidence. It's not just California. This year has seen the top 3 largest fires in Colorado history. And before 2002, Colorado never had a fire larger than 100,000 acres. Remarkably, in October, there were 3 burning simultaneously. In addition to record heat, the Arctic saw record fires this year, releasing even more CO2, which exacerbates the problem. And fires have been extensive across South America this year as well. This is the Pantanal, the world's largest wetland, a huge store of carbon and diverse species, and it had its worst fire season in October on record. And this is a wetland. It's not just fires. Many places around the world have seen incredible floods this year, especially in East Africa. Storms are getting more destructive as well. This summer, a derecho, which is a large organized wind and thunderstorm complex, poured nearly 800 miles across the country, causing over $7.5 billion of damages. This has never happened before. The season now shares the record with 1916 for the most landfalling named systems in the US in a single year. 7 of those were hurricanes that rapidly intensified, meaning they blew up from tropical storms into major hurricanes, in some cases in less than 36 hours. All of this is caused by CO2 making the oceans and the atmosphere hotter. And these destructive storms appear to be increasing. In early November, the strongest tropical storm ever recorded on the planet struck the Philippines. Last winter in the United Kingdom, it was struck by 2 powerful storms, though while not called hurricanes, were just as powerful and destructive. One was even the equivalent of a Category 4 hurricane in February in the North Atlantic. And finally, and ominously, this year saw that the melting of the Greenland ice sheet has become irreversible. Over the next few hundred years, this melting ice will raise sea levels at least 20 feet. Folks, we're in the beginning of the Great Disruption. It's happening now, and it's getting worse faster than nearly everyone anticipated. So where could it go from here? If we don't do anything different, the planet could be as much as 7 to 8 degrees hotter within 80 years, the lifespan of someone born today. Climate scientist Michael Mann has stated that if this happens, it will constitute the end of civilization as we know it. The reason being that the planet is changing too fast for us and for nature to keep up. Here's an example of one of the impacts of rapid change. This study was released this spring, showing that trees and forests might not be able to adapt to such a rapidly changing planet over the next few decades. More personally, that may be happening to humans as well. We've adapted to a predictable range of temperatures and environments which may change so rapidly over the next few decades as to prevent us from keeping up. The range of temperatures that make human flourishing possible is quite narrow, and climate change is closing that window. Here's an example. A new study shows just how unlivable rapid temperature rise might become. 1 billion people may be living in areas with insufferable heat within the next 50 years. If they can't live where they're living now because of the heat, what will become of them? It is predicted that there may be at least 1 billion climate refugees around the world within the next 30 years. And this is within a current rising anti-refugee sentiment around the world. This all points out so clearly what this is about. Addressing climate change is about justice for humans and all the other forms of life we share this small planet with. Finally, I'll just put this out there from Chase Bank, not a well-known environmentalist organization, certainly, but back in February, they leaked a report that shows that the climate crisis may be an actual threat to the survival of the human species. So now let's talk about how we're addressing this crisis. It certainly strikes me that our default response right now is minimization of the crisis. This is a real picture taken in my home state of Washington during severe fires in the Columbia River Gorge in 2017, which I think is a pretty good metaphor for this mentality of minimization. It also appears that there is psychological bargaining going on. The idea that there are things that we can do to stop the bad things from happening, but that don't actually require us to change anything about the way this society lives and works. Most obviously being, hey, trees are good, they suck up carbon, can't we just plant a bunch and call it good and we can go on living pretty much like today? Well, no. Yes, we need to plant trees, a lot of trees, but we must have other far-reaching changes to our current systems, starting with ending with the use of fossil fuels. Planting trees alone won't allow us to continue to burn fossil fuels as we are now. Some will then say, well, surely there's a technology that will allow our current system to continue. And that's true. There is a technology that is being developed that allows us to capture carbon dioxide as it's being emitted. But there's a hitch. This is a project in Australia being done by Chevron right now. They spent $2.5 billion to sequester 4 million tons of CO2 from this operation. That's $625 a ton for every ton of CO2 sequestered. If we start to look at the scalability issue of this technology, globally, we're emitting 37 billion tons of carbon dioxide a year. At this price, to sequester 1 year's worth of all emissions is $23 trillion. So that's $23 trillion for every year we burn this much fossil fuels. Now, perhaps as the technology gets more refined and sophisticated, that price per ton could come down. But certainly you can begin to see that we're not in a sustainable position to spend anywhere near this amount of money to try to capture our CO2 emissions. And then there's this in vogue phrase called net zero. Net zero sounds smart, like we can keep on doing what we're doing, but we'll just plant enough trees and develop technology in the future that will balance out all of the pollution that we're emitting, and nothing has to change. Here's how net zero is supposed to work. We emit CO2 as we do now, and then we suck that amount out of the atmosphere somehow later this century. The problem is that there is nothing, technology or otherwise, that can suck out anywhere near the amount of pollution we are putting up that will enable us to continue as we are now. And further, net zero only keeps temperatures where they are now, which, as we've seen, is pretty grim already. It does nothing to bring excess CO2 out of the atmosphere. Net zero is important in the sense that there will always be some incidental carbon emissions from ourselves and the planet that we must work to offset. But the thrust of our action shouldn't be to try and offset continued pollution, but rather to reduce the pollution that is already there. A recent report states the term net zero is used by the world's biggest polluters and governments as a facade to evade responsibility and disguise their inaction or harmful action on climate change. Ultimately, there is another response available, and that is acceptance that we have to change. The United Nations is leading this response. A report from 2 years ago lays out clearly what we have to do: decarbonize, which means removing all fossil fuel use from our societies no later than 30 years from now. This is radical, but necessary, as we've seen. That recommendation builds on the 2015 Paris Accord, in which 195 nations on the planet agreed to do everything possible to keep temperature rise below 2 degrees Celsius, and ideally to strive for keeping the temperature increase below 1.5 degrees Celsius. As we've seen, we're already close to that threshold. And it's important to note that as of this recording, the US has officially exited the Paris Accord, the first signatory nation to do so. So why are we trying to keep it to 1.5 degrees Celsius temperature increase? Well, it'll have fewer negative impacts due to intensity and frequency of extreme weather events, fewer impacts on resources, ecosystems, biodiversity, and food security. We're trying to keep this as manageable as we can. So the 2018 UN report laid out a decarbonization pathway to keep us below 1.5 degrees Celsius, which means the world must stop using all fossil fuels by 2050. To get a head start on that, we must reduce our use of fossil fuels by nearly 50% by the year 2030, which is 475 weeks from now. And we have not yet begun to lay out an organized plan of decarbonization. To meet that target, we'll need to reduce CO2 emissions by 8% a year over the next 10 years. And again, we haven't even started an organized effort. This year, the pandemic does look like it may have reduced our emissions by about 8%, although it doesn't look like it's going to last. And a pandemic is not an orderly pathway to decarbonization. It's a terrible way to do it. The urgency only increases when we realize that we might initially overshoot the 1.5 degrees Celsius target because of committed warming due to our current emissions. And adding further urgency, new research reveals that waiting until 2050 to end all fossil fuel use may be too late to even avoid crossing the 2 degrees Celsius temperature increase. Instead, this report that says we may have to end using fossil fuels no later than 20 years from now. This is right in the middle of many of our professional lives, and certainly for our students who are graduating today. This is going to bring about incredible change. But the only other choice now is to hope that somehow we can survive if we don't change. Even to keep the temperature increase below 2 degrees Celsius will require ending fossil fuel use as soon as possible and doing everything possible to draw down excess carbon out of the atmosphere, negative emissions, through planting trees and other natural-based solutions. Because remember, as of yet, there is no scalable carbon-sucking technology, and we can't continue to make it worse by continuing to burn fossil fuels. Ending fossil fuel use and working to draw down excess CO2 is of the most urgent importance, because only by stopping the temperature rise can we know for certain what conditions we need to adapt to. Until we know, we'll just waste time and energy chasing our tails with well-intentioned but ultimately wishful thinking attempts at adaptation. To kind of put all of this into perspective, I'll use climate activist Greta Thunberg's words from earlier this year that demonstrate clearly what we must do to help stem the crisis. Let us be clear, she said, we don't need a low carbon economy. We don't need to lower emissions. Our emissions have to stop if we are to have a chance to stay below the 1.5 degrees Celsius temperature target. And until we have the technologies that at scale can put our emissions to minus, then we must forget about net zero. We need real zero. It won't happen overnight, but this is something that we've got to begin working toward. So with urgency from those words, we must begin to imagine a zero carbon landscape architecture. Work that does not use fossil fuels for anything, and work that does its best to draw down carbon from the atmosphere. That's it. That's the underpinning of zero carbon landscape architecture. This is not going to happen quickly, obviously, but remember, we have 475 weeks to figure out how to cut 50% of carbon from our work if we are to do our part. So this is part 2 of our presentation. What does all this mean for materials and construction? Well, what it means is that we've got a lot of reimagining to do. Because when we talk about dramatic changes to materials and construction and having goals of sequestering carbon, then we have to begin thinking about design in new ways, which will lead to new directions for discussions about function and aesthetics. In turn, that will demand changes in landscape architectural education, practice, and very importantly, our ethics. Zero carbon landscape architecture is the future. We just have to invent it. So what I want to do now is to walk us through what decarbonization could mean for landscape architecture. First of all, it's a breakup story. We have to break up with fossil fueled fire, the source of so much modern life and the cause of the climate crisis. Decarbonization means we have to stop using coal, oil, and natural gas. No biggie, except that those underpin our entire profession right now. We use those to create and deliver our materials and power our construction machines, and we have to stop using them. And right away, many people's minds turn to the hope of renewables saving the day, meaning we can still work pretty much as we are now, but not so much. This is why energy literacy is becoming so important to our profession. Renewables generate electricity, and electricity is an amazing thing in our lives. It is a big part of what it means to be modern, but electricity isn't fire. And despite how we rhapsodize about modern technology, we are absolutely still living in a fire age. It is fire that does everything cool for us, including generating most of our electricity right now. Fire moves our machines and is used to fabricate our materials. Fire is what enables the modern world to move fast with vast amounts of stuff. Electricity alone so far has not done any of that in any scalable sense. Electricity is not a fuel, and that is something fundamental that all of us must come to terms with. It is fuels that power our world, and it is fossil fuels that are causing the crisis. Yes, the future is electric, but we've got a long way to go. Right now, solar and wind globally provide about 10% of all the energy that humans currently use, less than 10%. So let's look at the USA energy system. Today, fossil fuels provide 80% of all the energy used in the USA, 80%, the use of which is heating the planet. You see that 8% of the current energy mix is nuclear-powered electricity. To me, nuclear must be phased out. The waste issue has never been solved, and as you'll see in a little bit, building new nuclear plants is insanely carbon intensive, which should rule that avenue for energy out. So what we have left is renewable energy. It provides 11% of our total energy consumption right now. Unfortunately, of that 11%, about half of that comes from biofuels, which emit CO2. That means much of our renewables right now are actually contributing to the crisis. Yes, biofuels such as corn ethanol and biodiesel have potential to be carbon neutral, but when current practices are considered, the conclusion is that US biofuel use is associated with a net increase rather than a decrease in CO2 emissions. So we can't actually use them right now. Without that, then you'll see how very little actual renewable energy makes up of our current energy mix, a little over 6%. And of that, solar and wind account for just 4% of the US's total energy supply. All of that, what I just told you, to learn that we only get 4% of our entire energy supply from wind and solar. And even then, wind and solar are not self-replicating at the current time, meaning that it has never been proven at an industrial scale that wind and solar electricity generators can create the energy needed to power the entire process to build more. Right now, we use fossil fuels in all facets of creating solar and wind electricity generators. So the question we've got to be asking is how much energy can renewable electricity possibly replace? The answer right now isn't real encouraging. Electrifying everything won't be easy. There's the intermittency problem, which is almost like a sign from the planet to slow down and adapt to these kinds of realities. The intermittency problem leads to storage issues. There are currently no industrial scale technologies for electricity storage. There's a big spatial problem that has not been addressed at all, and that there are already large footprints of solar and wind across the country, and still they just provide 4% of our energy usage. What would the spatial footprint be if they provide 50% or more of our energy usage? Look, we'll have to electrify everything, but we have to realize that it will be a great deal less energy in the future, leading to massive energy efficiency programs and conservation practices. So what this is doing is this is implicating us as landscape architects. How are we going to function in the low energy future? Well, we're fortunate to have a map produced by the scientists at Cambridge in the UK. These folks have created a report entitled Real's Absolute Zero. And the premise is that we can't wait for breakthrough technologies to deliver net zero emissions by 2050. Instead, we can plan to respond to climate change using today's technologies with incremental change. Boundless optimists will be disappointed as there are no magic technologies that ride to the rescue, but rather this report talks about GASP, doing with much less of everything, and even doing without certain things completely, as we'll see. But it does provide a real pathway to zero carbon within 30 years. So here's what decarbonization means to these Cambridge scientists. As we've talked about, everything has to be electrified. Everything that can be has to be. All transportation that's possible, all buildings, all machinery, all industrial processes. Many materials probably will have to be reduced. We can make steel with electricity, but there's no guarantee how much electricity we'll have. Certainly other materials can be made with electricity, but again, they may be limited by the amount of energy available. Some material processes cannot be zero emissions at all, and they'll have to be eliminated. That means cement, blast furnace steel, and most plastics. And finally, fossil fuel transport would have to be curtailed. Air transport right now at any kind of commercial scale cannot be electrified. Cargo shipping is heavily dependent on fossil fuels, and all of our machinery and long distance trucking right now are dependent on fossil fuels. So this is a pretty stark pathway to decarbonization, but it's one that we must take seriously if we're going to do our part. One of the important things that we've got to understand as a profession is the concept of embodied carbon. Embodied carbon is the sum of all the greenhouse gas emissions resulting from the mining, harvesting, processing, manufacturing, transportation, and installation of our building materials. Understanding this is going to be central for us as a profession as we move into the zero carbon era. Recent research by Atelier 10 in Landscape Architecture magazine shows an average LA project's embodied carbon in this breakdown. Materials comprise 85% of our embodied carbon, transporting those materials another 5%, site work and construction add an additional 10. So we've got a very serious right now embodied carbon situation in all of our landscape architecture projects. We find all of our familiar materials and construction methods implicated by this: steel, concrete, plastics, big trucks and machines. I'll go through each and give a little explanation. So if we talk about steel and cement, they're responsible for an enormous amount of carbon emissions, about 15% of the total global emissions every year. If we look at steel specifically, making original steel via the basic oxygen process produces a large amount of emissions. Steel can be recycled via electricity-powered processes that can be virtually carbon-free, carbon emission-free, if the electricity is renewably generated. But there may be pretty sharp limits on the amount of renewable electricity available and the amount of recycled steel available. Looking at concrete, carbon emissions are unavoidable from the production of cement, which is of course the core of concrete. And that's the whole point of the process of making cement, is to drive out the impurities caused by carbon dioxide. So producing a ton of cement generates a ton of CO2 emissions. And there are as yet not any scalable emission-free alternatives. The Absolute Zero report states that all existing forms of cement production are incompatible with zero emissions. To comply with decarbonization, all conventional mortar and concrete must be phased out no later than 2050. And your reaction is probably the same as mine. It's like, holy crap, what are we going to do in a concrete-free world? We've got less than 30 years to figure it out. This is perhaps our most pressing challenge, and there's a lot of smart people looking at emission-free alternatives, but right now, nothing that I've seen shows that this is going to be able to scale to the amount of concrete that we currently use. 99% of plastic materials are derived from fossil fuels, primarily petroleum, and there's no emission-free method to make them. Now we'll look at our common construction equipment. There's a lot of weight to be moved around without fossil fuels. While smaller machines like skid steers and perhaps backhoes can be electrified, it appears that the large equipment used for earth moving and transport might not be able to be electrified because the machines are too heavy for battery power and can't be plugged in or attached to an overhead catenary line. And further, the embodied carbon emissions involved with building an all-new electric fleet of heavy machines would involve huge emissions that we can't afford. So with the new approaches to our materials and construction, we need to add another goal, which is zero carbon landscape architecture, and that's called drawdown. Drawdown simply means pulling down excess carbon dioxide from the atmosphere and sequestering it in materials like woody plants and soils. The lowest tech but currently only scalable way to do this is by using trees. For example, a sugar maple can sequester 53 pounds of CO2 per year, a 3-inch diameter sugar maple, 53 pounds of carbon dioxide a year. Over 20 years, that tree could sequester approximately a ton of carbon. Here's what a ton of carbon looks like. So for every amount of that material on a construction project, you'd need one large deciduous tree planted somewhere to live for 20 years just to offset that 1 ton of carbon. Up to now, that kind of simple equation has not been addressed by our work. We are slowly beginning to awake to this reality. Landscape architect Craig Pocock says the fundamental problem is that we tend to specify more carbon in the form of materials within our work than the planting of our work can possibly ever offset. This is true for even the greenest type of LA projects, such as green roofs and rain gardens that have large embodied carbon footprints from materials and construction methods. This is pushing us toward a new era in landscape architecture, that of carbon accountability. We have been unaccountable for our carbon emissions for too long. Thanks to the great work of landscape architect Pamela Conrad, we are beginning to see the era of carbon accountability emerge. Her work on climate positive design will long be remembered as a turning point in our profession. The overarching goal of her Pathfinder app is to help landscape architects design landscapes that will become carbon neutral by 2030 and thus do their part to keep the global temperature rise under the critical threshold of 1.5 degrees Celsius. This simple animation can help us visualize the process. We'll draw a line representing CO2. Above that line are CO2 emissions into the atmosphere. Below that line is sequestered CO2. Along the bottom is time moving forward. The red block represents an LA project that has some CO2 emissions over the project development life. This represents the project's initial embodied carbon footprint. And depending on the materials and construction methods and the amount of plant material used, that embodied carbon footprint can be drawn down and sequestered, rendering the project carbon neutral. But Pamela Conrad has a great quote about carbon neutrality. Carbon neutrality isn't really a good goal for landscape architects, it's too low of a bar. Landscapes can capture and sequester carbon through trees, plants, and soil, and that ability has been completely excluded from the conversation. Such a project that she is describing there would look like this, where it goes far beyond merely offsetting its own carbon footprint and begins to bring down global emissions. That idea leads to this, that perhaps one day LA projects could begin with no embodied emissions and could begin sequestering global emissions on day one. That's a pretty great dream. But how is this possible? I believe that once a challenge has been laid out like it is now, solutions will follow. We just haven't really talked about this before. We can unleash our imaginations to see how this can happen. And we can look to history. Central Park, perhaps the best example of landscape architecture as a social ideal, began its life as a near zero carbon project. It is possible. So as we've seen, decarbonization and drawdown will touch everything we do and how we do it. But our profession predates fossil fuels and nothing we do intrinsically requires them. So now I'm going to turn it over to Rob, who will dive more deeply into the implications for landscape architectural practice, education, and organizations in a zero carbon future.
Hello again, everybody. I'm now going to focus on the last section of this presentation, implications for practice, education, and our organizations, beginning with everyday emissions. Depending upon the source, an average American emits between 16.1 and 20 metric tons of carbon dioxide per year. If you consider all greenhouse gases, it may be as high as 23 metric tons. And using the Bureau of Labor Statistics, we can find there are about 19,000 landscape architects and 566 in Pennsylvania and 25 in Delaware. If we use those values I just presented, we could very easily estimate what we landscape architects are responsible for emitting each year and focus even further onto the future, what we might be responsible for emitting between now and 2050 in the next 30 years. And if we focus on one of those numbers, we could then even figure out how many trees would need to be planted over the course of 1 year in order to sequester an equivalent quantity of carbon dioxide, or if we have more time, 100 years, it'd be considerably less, but it would still be a high number of trees. And these emissions have consequences, and one consequence is melting September Arctic sea ice loss. So this value will correspond to about 1 million square meters of September Arctic sea ice loss, which is equivalent, to help you visualize this, to the area between Washington Square on the south, Franklin Square on the north, and City Hall on the left in Philadelphia, the area highlighted in blue. So it's pretty significant. So if we started to think about reducing our emissions and have a goal of 3.7 metric tons per person per year, what would we landscape architects have to do? We'd have to reduce our emissions about 14 metric tons between now and 2030, and about 1.5 metric tons per year. That's just CO2. It'd be a little higher for all greenhouse gases. And if we looked further to 2050 with a goal of 2.1 metric tons per person per year, which is a global equitable distribution of emissions, we would have to reduce our emissions about 15 metric tons, or about 0.5 metric ton per year. Considering all greenhouse gases, it'd be higher, up to about 0.75 metric ton per year. How could we do it? What could we focus on? So one of the session materials that we've provided is an article by Winston Nicholas, and they provide some high impact actions such as having one fewer child, living car free, not flying or flying considerably less, and becoming a vegetarian. These are the sorts of drastic actions that all would occur or need to occur in the future in order for an average American to reduce his or her carbon footprint in the coming years. But if we then think about what we do every day in our practice, the operations, our overhead, what is our carbon overhead? We can look to at least one precedent, and that is Primera's online carbon footprint. And we see that employee commutes in the 3 offices, including field commuting, transportation, results in, again, some September Arctic sea ice loss, and thousands of trees would be needed to remove an equivalent quantity of that CO2. If we also think about the electricity usage in each of those offices, that corresponds to some more September Arctic sea ice loss, more thousands of trees that would be needed. And if we wanted to generate an equivalent quantity of electricity through renewable resources, in particular solar panels, we'd need thousands of square feet to do that. We may not have the space to do it. So the implication of this is we've got to commute less, we've got to use less electricity, or find a renewable way to do it in our offices in the future, the near future. What about certification? CITES is the most comprehensive system for creating sustainable and resilient land development projects, but it's sustainable for how long exactly? Is it sustainable for 500 to 1,000 years? And resilient to what degree? And I mean that literally, I'm referring to a temperature of 2, 3, or 4 degrees C. If we look to a paper written by New and others in 2011, we see that the authors state global temperature rises of 3 to 4 degrees C are much more likely than 2 degrees C in the future, and that all models they cite warm to 2 degrees Celsius between 2045 and 2060. That's 25 to 40 years from now. And all but 2 of those models reach 4 degrees C before 2100. They also note that the most sensitive model reaches 4 degrees C by 2061. That's 40 years from now. Currently, we're at an increase in global average mean surface temperature of 1 degree Celsius. So there'd be a considerable amount of warming in the next 40 years if that were to occur. Later in the paper, and more appropriately relevant to this conversation, they note that adaptation responses have to consider a wider range of possible futures, and that responses that might be appropriate for a 2 degree C world would be maladaptive in a 4 degree C or greater world. So that begs the question, if we design projects to last 25 to 40, even 50 years, and anthropogenic global warming continues unabated, are the embodied emissions that we're investing in these projects really worth it for such a short-term gain? The emissions last over 100 years in the atmosphere, doing their work, making the planet warmer, and all the related consequences. This is not resilient design. This is, by definition, transient design. It's here for a short term during changes. We do not know when or if emissions will stop, and we're designing for a short period of time here for a change. And those specifications for transient design really need to specify a project life in years. How long will this project last? And a global mean surface temperature. And any regional specific criteria. So for us in Pennsylvania and Delaware, it may include anticipated sea level rise from a reputable source. And finally, given the short-term investment in these emissions for these projects, we've got to reduce the embodied emissions to an absolute minimum of these projects. Further on, we've got to alter sites and any other certification for the future so that it is zero carbon. They need to be more aggressive. So things like specifying plastic lumber made with recycled content may not be the best thing to do, based upon one study that I found that showed that plastic lumber had a greater global warming potential in comparison to ACQ treated lumber. For those things trying to deal with precipitation on site, like permeable pavers that are made out of concrete and asphalt, those possess an embodied carbon. Is that worth it? And other things trying to encourage infiltration through the use of bioswales and water quality ponds and constructed wetlands, all of which are found, according to a meta-analysis of 28 studies by Kavehi and others a few years ago, to have net positive carbon footprints. They may be doing more harm than good. Regarding manufacturing materials, in the future, the percentages that are noted for reducing emissions here, number one, need to be increased. It's great that we're reducing emissions and expecting that. And the same thing is true for energy consumption, but we need to increase the required percentage noted in the certification manual. And the same thing is true for renewable energy sources. And yes, we certainly like reducing the use of potable water, but when it comes to carbon offsets, we should not mention anything about carbon offsets. They are completely unacceptable because they do not alter the behaviors of individuals or corporations. They erode support for any more aggressive measures that might occur in the future to reduce carbon. And they also, most importantly, do not prohibit or prevent carbon emissions from being emitted into the atmosphere. What about in education? There's the Landscape Architectural Accreditation Board that has a good deal of power over not only one program, but all accredited programs in the United States, and they should use this power to their advantage to affect change within university programs. For instance, in Standard 1, Program Mission and Objectives, the educational objective D, the long-range planning process, the program shall engage in effective long-term planning. Well, those plans should include zero or negative carbon in operations and curriculum. Standard 3, professional curriculum. There's got to be some mention of climate science there, and then further down under professional curriculum. It can't be just one discrete item on this entire list of professional curricular topics. It's got to permeate every single category. So if you think about COVID and how COVID has affected your life, from the sales of sweatpants to haircuts, and how often you might get one, to virtual meetings, to anything else that you can imagine, the not flying or driving anywhere. It's affected our lives in so many ways, some more than others, obviously, but climate change and the climate crisis needs to affect all aspects of the curriculum for the future. Student and program outcomes. Yes, we want to qualify students to pursue careers in landscape architecture, but those careers are most likely going to adapt and evolve considerably in the next 25 to 40 years. We've got to prepare students for that. Are we now? What about the faculty? Faculty should certainly take it upon themselves to model environmentally just behavior, not traveling to conferences to present information that really has no long-term positive impact on research and education. That's one way of doing it. But they need to use their voice, their title, their standing, their visibility to begin modeling these environmentally just behaviors. And then further down, there is some mention specifically of conferences, but that conference attendance should be virtual and or overland and not encourage air travel, or we should just get rid of it. Standard 7, regarding the facilities and equipment, there's got to be some goal of the facilities becoming zero carbon in the near future, the next 25 to 40 years. And let's think about the accreditation team visits. So here's a list of the 15 individuals that visited my programs, our programs within the last 10 years. And all 13 of 15 traveled by air, resulted in 9.78 metric tons of carbon dioxide emitted into the atmosphere. That is including radiative forcing, which is increased global warming potential because the aircraft emissions occurred way high up in the atmosphere. And that's unique to aircraft emissions. Without factoring that in, it's 2.5 to almost 4 metric tons of carbon dioxide. And using the means here, I then can look at the accreditation on-site evaluations, of which there are 105 between spring 2014 and summer 2019, which included approximately 315 on-site evaluators, and determined that there's about 205.8 metric tons, again including radiative forcing. It was emitted just for the travel to these universities for 3 or 4 days, the on-site visits. Without radiative forcing, it's 67 metric tons. So that's got to change. They've got to be virtual. The format has to change, or the on-site evaluators need to be local. I also looked at paper, in case you're curious. I measured and counted every single sheet of paper that we used for our representative student work gallery for the on-site evaluation. And it worked out to be about 27 pounds, not metric tons, not kilograms, 27 pounds of CO2. This does not account for the electricity needed for the computers and the plotters and the printers, but just the paper. So we need to focus on bigger things and what really matters, high impact actions, not paper. What about lecture series? Well, here's the top 10 bachelor's and master's degrees according to the 2018 Design Intelligent rankings. And I just did some quick internet searches of these 4 programs and found that LSU had a number of lectures. Here's 3 that totaled 5.35 metric tons, just to get those individuals down to New Orleans. Cornell had, just from 1 lecture, it could have resulted in about half of that. This again includes radiative forcing. University of Georgia, well done. Local, 1 overland. What about the Buckeyes at Ohio State? Well, I did not go through the estimations, and I really don't need to see that these individuals probably traveled long distances, thousands of kilometers, and emitted lots and lots of carbon into the atmosphere. This needs to change. They need to be virtual, most likely how they were virtual this year. What about in our landscape architectural organizations? Well, the most obvious one of the affected organizations is going to be the American Society of Landscape Architects, and their biggest event each year is the annual conference on landscape architecture, as well as their expo, which draws, according to their claims, about 6,500 members to the conference location each year. So that's got to change, as well as the Diversity Summit, the Advocacy Summit, and the Public Awareness Summit. So the SLA needs to stop encouraging air travel to Washington, D.C. or other locations for members to convene. This needs to be done virtually and or regionally. And what are we talking about? What are we focused on in these education session topics? So according to, for the most part, the SLA's classification of these education sessions, according to the topics listed on the left, there are a lot that claim to focus on sustainable design and resilient design. But again, are they asking the right questions? Are they showing us how to adapt to a zero carbon future, how to reduce the embodied carbon in our projects and increase sequestration, as well as other aspects of the profession that we're touching upon here? No. The Council of Educators in Landscape Architecture also has an annual conference, and the number of attendees is considerably smaller than the ASLA's, but nonetheless, it needs to in the future be regional and or virtual. The Cultural Landscape Foundation also is an organization that has a number of exhibitions, lectures, and conferences. And although this number is likely reduced due to COVID this year, in the future, should these occur and individuals convene, it needs to be done overland and without the use of aircraft. And then the American Academy in Rome, although there's a small number of individuals associated with this, this is a good example of changing the perception of prestige rather than rewarding an individual or a small group of individuals with a high energy carbon intensive behavior like flying from the United States to Rome and back. We need to find other ways of adding prestige to an individual's professional or academic experiences and knowledge. Sigma Lambda Alpha, the National Honor Society of Landscape Architects, grants 16 travel grants each year, and these are for travel, but they need to, in the future, specify whether they're going to be overland in particular and not by air. In Landscape Architecture Foundation, there's two aspects I want to focus on here. Both relate to the Case Study Investigation Program, and that is the Landscape Performance Series. Using an alteration that occurred this year due to COVID, the site access and the research assistants and the investigators really encouraged to visit these sites and continue their investigations only if they were nearby. And maybe that should continue in the future so that any investigations that do occur are using sites that are nearby and accessible by overland travel only. And additionally, if you take a look at some of the case study briefs from which you can filter on the left side a number of different categories, you see that there are 72 projects tagged carbon sequestration and avoidance and 25 projects tagged energy use. What I mean by redundant is some of these projects occur in both categories, but upon clicking on one or more of them, you see that one of the often noted environmental performance benefits is that they sequester some quantity of atmospheric carbon. So here this project sequesters 9.19 tons. Keep in mind and compare this to the values I presented at the beginning here. That is about half, a little over, a little under, depending upon your source, what one average American is responsible for emitting each year. So that's not a lot. And if what we're not seeing is what this project had embodied, what the embodied carbon of this project was, what was emitted through the specification of materials, the installation, the construction methods, and the maintenance of these projects. We need to document that. And the Pathfinder tool in the climate positive design is beginning to do that, but the authors of this tool note that it is not, quote, for performing a greenhouse gas inventory of projects, but we need to do that. The Pathfinder tool, quote, is intended for relative comparisons to inform early design decisions. So as designs evolve and change, some of these proposed materials and plans or designs are going to change and may increase the overall carbon dioxide emissions associated with the projects. And there's a number of case studies that are presented here that obviously reduce the amount of embodied carbon and increase the potential sequestration through substitution of materials and increased quantity of trees and shrubs and other things. But it's important to keep in mind that the landscape architects who are responsible for this, and the authors note that there may be on average about 5 landscape architects working on each project, they're responsible, as is the client, for these emissions in addition to their normal everyday emissions. And these result in September Arctic sea ice loss. They result in labor productivity loss, particularly in equatorial regions elsewhere in developing countries in the world that rely upon agricultural, mining, quarrying, and construction labor. If it gets too hot, they're just not going to be able to work as much because of the heat exposure. And also, there are a large quantity of trees that would be needed over a long time to remove an equivalent quantity of carbon dioxide. And there's a number of statistics that are presented over the last year. You see that there's 1.56 million trees planned for planting, over 1,700 projects logs. But this is not even equivalent to the 1.91 million 3-inch caliper sugar maples that would be needed to sequester or avoid an equivalent quantity of carbon dioxide from the travel of attendees to ASLA annual meetings from 1960 to 2019. That's just meetings. So we've got to do more. We've got to make some radical changes. Let's summarize this presentation. beginning with 4 main points we want to emphasize about the climate crisis. The first is that global warming is irreversible, at least on a timescale of 1,000 years, and any actions that we take can only lessen the severity of the warming and the related consequences. We've got to act now, and our actions need to be radical. The special report on global warming of 1.5 degrees C states that limiting warming to 1.5 degrees C requires reductions and removal of CO2. We may have some methods to remove CO2, but they can't be scaled up. They can't be scaled up fast enough, and they are probably not economically feasible. We need to change our behaviors and have some radical changes in what we do. Third, atmospheric CO2 continues to rise despite behavioral changes to COVID-19. This indicates that the actions that do need to change have to be even more intense and sustained, and they need to be voluntary. And finally, the Earth will likely warm beyond 1.5 degrees C, and we need to be prepared for that and acknowledge that and act accordingly and act urgently. Now, our response to the climate crisis must include a number of things. How we heat our offices, how we power our offices, how we move about, particularly to and from our offices and home, as well as our job sites or prospective job sites, what we design and specify, and for whom, what and how our designs are constructed. We're talking about machinery there. The certifications that influence and inform what we design and how we build. The organizations and the operations of those organizations and how we interact with one another. What and how we investigate and learn, as well as what students learn prior to entering practice. Our response to the climate crisis must be honest. We must acknowledge that we are high-emitting, professional, privileged Americans. What we do as landscape architects inherently makes us responsible for emissions that are even greater than the average American. We need to stop patting ourselves on the back and recognize this and do something about it and change our actions. We don't have all the answers, and we do not have all the solutions to the problems that exist. We may have some, but we need to recognize this. We need to be reflective. We need to identify which personal and professional actions have a high impact and must change immediately, and we need to do this regularly. Our response has to be radical. So we're talking about fundamental, drastic changes that are needed. So we may be able to pick some low-hanging fruit and make some changes in emission reductions that are relatively easy. And we need to sustain those, but further down the line in the future, the changes that need to be made are going to be even more difficult if we really want to address the climate crisis. We have to be resilient. I'm not talking about it within the same terms as resilient design. We need to expect and confront challenges that occur, both socially among ourselves and how people interact within the profession and outside of the profession, between professions and the public, and we need to persevere. But we're also talking about changes that might happen around us regarding the climate, whether it's weather-related, hurricanes and tropical storms and derechos, rising sea levels and storm surges and so forth. We need to expect that. Power outages, the absence or lack of materials. And finally, our response has to be active. There will likely be little stasis due to frequent changes. We might have periods of a new normal where things are, we acquire some degree of comfort, but then there may be another unexpected change that we have to adapt and address. We want to end with a couple questions, 3 questions, in fact, that will help guide your reflection in the future on how to change and what to change, and to do this regularly. The first is, what practice-based and design changes to reduce your reliance upon fossil fuels are possible? Second, what personal beliefs, norms, and standards are preventing changes to your practice and design despite evidence that indicates the continuation of these beliefs, norms, and standards contributes to irreversible climate change and human harm? And finally, what actions will you take to change, disrupt, or stop inequitable, irresponsible norms and standards in your work and in the profession of landscape architecture?
We'd like to thank you all again for joining us. We'd love to hear from you. And so we'd love to keep this conversation going. Thank you all.
Thank you again for the opportunity to listen to us and hear our perspective. I hope, and we hope, that you take this information seriously. Please feel free to contact us again in the chat or by contacting us via email. Thank you.